In this video, we are going to talk about multiplying radicals, adding and subtracting radicals, as well as a combination of multiplying and adding and subtracting radicals. So the first thing we're going to talk about is kind of our rule about multiplying radicals. So when we multiply radicals, our indexes have to be the same. So if you notice, these are both n's. And when we multiply radicals, we're just going to basically multiply the numbers underneath the radical. So for example, in number 1, if I look at number 1, if I first look at their indexes, I have a 4 and a 5. So since these indexes are not the same, I cannot multiply these, because the indexes do not match. But in number 2, the indexes do match. Therefore, I could multiply these and I'll get the 5th root of 10. So let's give this a try. Again, remember we can only multiply if our indexes match. So in number 3, these are both square roots. Since they're both square roots, I can multiply them together. So when I multiply them together, I'm going to get 720. Then remember, when you multiply your variables, you're going to add the exponents. So I have x to the 4th and y to the 5th. Now that I've multiplied them, I want to simplify it. So I'm going to do the same thing that we worked on the other day. I'm going to break down, well, I know 72 breaks down into 72 and 10. Or sorry, 720 breaks down to 72 and 10. 72 breaks down to 8 and 9. 10 breaks down to 2 and 5. 3 and 3. 2 and 2. Okay. So now this is a square root, so I'm looking for pairs. So I have a pair of 2's, a pair of 3's, and then another pair of 2's. So I'm going to have a 2, and a 3 on the outside. And then I'm going to have this 5 left on the inside. So now I'm going to look at my variables. I have an x to the 4th. Well, the square root of x to the 4th is x squared, because if I have 4 x's, I would have 2 pairs. Then I have this y to the 5th and y to the 5th. Well, that would give me 2 pairs with 1 y left over. So now I need to multiply those front numbers together. So 2 times 2 times 3 would give me 12. So we have 12x squared y squared square root of 5y. And that would be my final answer. Let's do the same idea in number 4. So number 4, I'm going to multiply these together first. So I'm going to get the 4th root of x to the 7th and y to the 4th. Because I have 2 and 5 is 7, 3 and 1 is 4. Now when I'm simplifying this, remember I'm looking for groups of 4. So if I have x to the 7th, that means I have one group of 4 and I have 3 remainders. So 3 would stay inside. Y to the 4th, I have one y group with no remainders. So this would be my final answer for number 4. In number 5, it's going to be really similar, except for the fact that now I have these numbers out in front. So when I multiply, I'm going to multiply those numbers out in front. So I'm going to get 12 square root of 16x squared. Because remember, x and x will give me x squared. Well, actually, 16x squared, that's a perfect square. So I'm just going to have 12 times 4x. Because the square root of 16 is 4, and the square root of x squared is x. So actually, I'll have no radical left in my answer, and my final answer will just be 48x. And that'll happen sometimes if we have a perfect square underneath our radical. Now I'd like you to pause the video now and try 6, 7, and 8. When you are done, play the video and check that you got your answers correct. All right, number 6, when I multiply them together, I'm going to get the cubed root of 750 x squared y to the 3rd and z to the 6th. Well, if I want to break down 750, well, I know 15 and 50. 5 and 10, 5 and 3, 2 and 5. And then again, I'm looking for pairs. So I have a pair of 5s, and actually that's it. So my pair of 5s will come out, so I'll have a 5 on the outside. And on the inside, I'm going to have a 2 times 5 times 3. So 2 times 5 times 3 is 30. So I'm going to have a 30 on the inside. Now let's look at my variables. So right now I have a cube root, so I'm looking for groups of 3. So if I look at my x, I don't have enough for a group of 3. So my 2 x's are going to stay on the inside. With my y's, I have 3 y's, so that's one group of 3. So 1 y comes out. And my z's, I have 6 of them, so that's 2 groups of 3. So 2 z's come out with no remainder. So this is my final answer for number 6. Number 7, when you multiply them together, you'll get 14 square root of 18x3y3. Now I want to break down 18, so 9 and 2, 3 and 3. So on the outside, I'm going to have 14 times 3. Remember, whatever you take out from under the root is going to multiply by whatever is outside of the root. And on the inside, I'm going to have this leftover 2 on the inside. Then if I have a square root and I have 3 x's, one pair will come out, one remainder stays in. Y to the third, I'd have 1y come out, 1y stay in. So my final answer would be 42xy, square root of 2xy. And number 8, multiply them together, and I'm going to get 1,575 x to the 6th, y to the 7th. And I'll break down this, so I'll break it down back into 45 and 35, 9 and 5, 7 and 5, 3 and 3. And again, this is a square root, so I'm looking for those pairs. So I have a pair of 3s, and I have a pair of 5s. So that means a 3 and a 5 are going to come on the outside. And this 7 that's left on the inside is going to go on the inside. Then if I'm looking at my variables, I have 6 x's. Well, that'll make an even group of, or 3 groups of 2 with no remainder. I have 7 y's, so that'll be 3 groups of 2 with 1 y remaining. So my final answer would be 15 x to the third, y to the third, square root of 7y. All right, now let's look at some adding and subtracting. So when adding and subtracting, the biggest thing to keep in mind is you can only add radicals with like insides and outsides. So with multiplying, it just had to have the same index, but it has, when you add and subtract, it has to have the same radicand. And if we remember from our vocab yesterday, the radicand is the inside of the radical. So it's what's underneath. So if we're looking at number 9, I have both square roots, and they're both the square root of 5x. Now we're just going to treat this like a variable. So basically I'm just going to do 3 minus 2, and I'm going to get 1 square root of 5x. I don't subtract anything that's underneath the radical. That's just going to stay how it is. But now if I look at number 10, I have a square root of 7 and a square root of 5. Since I'm adding, they would have to be exactly the same. So this is fully simplified. So this cannot be simplified anymore. That would be my final answer. Similar to number 11, if I look at, I have a cube root and a fifth root. Just because what's underneath is the same doesn't matter because my indexes aren't the same. My index, same index and same radicand. So this one is also fully simplified. Same with number 12. Cube root, square root cannot be simplified anymore. 13 can be simplified because, again, I have square roots and the same thing underneath the square root. So I'm going to do 3x plus 4x, which is 7x. So it'll be 7x square root of xy. 14, I have a fifth index here and a fifth index here, and what's underneath is the same, so I'm good to go. So I'm going to do 17 minus 15, so that's 2, and then the fifth root of 3x squared. And this would be my final answer, because what's underneath the radical cannot be simplified anymore. Now, at first glance, it looks like 15 and 16 can't be simplified, but in fact, they actually can. I will be able to add and subtract these together once I simplify what's under each of these radicals. So first, I'm going to focus on simplifying the radicals to check to see if they can be added and subtracted together, because right now they cannot be added and subtracted together. So I have a pair of 2's, so square root of 12 will simplify to 2 square root 3. In 75, I have a pair of 5's, so that'll simplify into 5 square root 3. And then square root of 3, 3 is prime, so that won't simplify, so I'm going to have minus square root of 3. Now remember, there's like a 1 in front of the square root of 3. So now that I can see what's under my radicals are all the same, square root of 3, square root of 3, square root of 3, I'm just going to subtract what's on the outside. So I have 2 plus 5 minus 1 is going to give me 6 square root of 3 as my final answer. So before you say it's fully simplified, make sure that you check to see if any of your radicals can be broken down. If they can be broken down, then simplify those, and then hopefully things should add together. We're going to do something similar in 16, except for now I have cube roots. So instead of looking for pairs, I am looking for groups of 3. So I have 3 5's, so a 5 comes out, and it's going to stay the cubed root of 2. And in this case, I have 3 3's. So 3 on the outside. Oh, sorry guys, I made a little mistake. 6 is 3 and 2. So 3 cubed root of 2 minus, and break that down. Again, I have 3 2's with a 2 left over. So 1 2 comes out, 1 2 stays in. Sorry, I didn't mean for that to be a different color. So I have 5 cubed root of 2 plus 3 cubed root of 2 minus 2 cubed root of 2. So again, that's 5 plus 3 minus 2. So 6 cubed root of 2. All right, so now we're going to be putting it all together. So now we're going to be using some of our polynomial operations with our radical rules. So if I look at number 17, I can see that I have a number outside the parentheses. Anytime we have a number outside the parentheses, I'm going to distribute that number in. So if I have square root of 6 and I'm multiplying it by 7 square root of 3, what I'm really going to do is I'm going to have square root 7 square root of 18. Since 6 is inside the radical, I'm going to multiply it by the other number that's inside the radical to get 18. Then I'm going to do square root of 6 times 6. Well, that's a little bit tricky because this is not a radical number and the square root of 6 is a radical number. So if I multiply, just like when I multiply a variable times a number, when I multiply a radical times a number, it just becomes 6 square root of 6. Now we have to make sure that this is fully simplified, which 6 would break down into 2 and 3, so that won't simplify. But 18 can simplify by taking out a pair of 3's. So I'm going to have a 3 multiplied by my 7 on the outside with this 2 left on the inside with 6 square root of 6. So I'm going to have 21 square root of 2 plus 6 square root of 6. Now this simplifying didn't allow me to add these together, but it's still necessary to fully simplify. So now we're going to use the same idea, except for when I have two things multiplied by two things, or a binomial times a binomial, I need to double distribute, or some of you guys call it FOIL. So first I'm going to do 3 times 2, which will give me 6. Then I'm going to do 3 times 4 root 5, which will give me 12 square root of 5. Notice the 3 is an outside number, so I only multiplied it by the outside number. I did not multiply it by that 5. Now, just like when we do operations with polynomials, I need to do 2 root 5 times 2 and 2 root 5 times 4 root 5. So 2 root 5 times 2 is going to give me 4 root 5. And then 2 root 5 times 4 root 5. Well, I'm going to multiply the outside numbers. So 2 times 4 is 8. And root 5 times root 5. Now I'm going to use my multiplication rules. So I'm going to do 5 times 5. So I'm going to have plus the square root, oh, sorry, not plus. I'm going to have 2 times 2 is 8. 5 times 5 is going to give me the square root of 25. Now I want to simplify this just like when we do operations with polynomials. So I want to look, well, I can combine these middle guys. And so 12 root 5 plus 4 root 5 is 16 root 5. And then I'm going to bring down this 6. Now this can be simplified because 25 is a perfect square. The square root of 25 is 5. So really this is the same as 8 times 5, which we know is 40. Well, 40 is a like term with 6. So I'm really just going to get 46 plus 16 square root of 5. Now 21 looks like it's a different type of problem, but it's really the same because we know when something is squared, what we have to do is we have to write it twice and multiply it times itself. So when I write this twice, I'm going to do the same thing I did in number 19, and I'm going to double distribute or FOIL this out. So 2 root 3 times 2 root 3. Remember, multiply your outside numbers, multiply your inside numbers. So I'm going to get 4 square root of 9. Then I'm going to do 2 root 3 times negative 5. So that's going to give me negative 10 square root of 3. Now I'm going to do this negative 5 times 2 root 3, which will give me another negative 10 square root 3. And then I'm going to do negative 5 times negative 5, which will give me positive 25. All right, now I need to simplify this. So the first thing I'm going to do is, well, I know the square root of 9 is equal to 3, so this is really the same as 4 times 3. I also can see that I have some like terms. I have negative 10 root 3 and negative 10 root 3. Now notice they're both negatives. If one was negative and one was positive, it would become 0. But since they're both negative, I'm going to get negative 20 root 3 plus 25. Now, similar to the last example, I know that this is 12, so 12 plus 25 is going to give me 37 minus 20 root 3, and this would be my final answer. Now let's try this last one. So 23 is really similar. We're just going to have some more simplifying we're going to need to do in the end. So first thing I'm going to do is do root 6 times 4 root 3. So again, my root 6 is only going to get multiplied by the 3. So I'm going to end up with 4 square root of 18. Then I'm going to do root 6 times negative root 10. So that's going to give me negative square root of 60. Then I'm going to do the same thing with this 4 root 5. 4 root 5 times 4 root 3. Multiply the outside number, so 4 times 4 is 16. Multiply the inside numbers, so 5 times 3 is 15. Then I'm going to do 4 root 5 times negative root 10. So that's going to give me negative 4 square root of 50. Because remember, that's kind of like there's a negative 1 in front of this root 10. So 4 times negative 1 is negative 4. 5 times 10 is 50. Now I need to simplify down these radicals because kind of like we did the problems with the adding and subtracting, none of these are going to add together, but they can be broken down or simplified. So I need to simplify each of these as much as possible to see if any of my radicals will add together. So 18 will break down into 9 and 2, 3 and 3. So my pair of 3's will come out. So I'm going to have 4 times 3. My 2 will be on the inside. When I break down the 60, I got a pair of 2's, so I'm going to have a negative 2 on the outside, 15 on the inside. Now, square root of 15 doesn't break down, so this is just going to stay as 16 square root 15. And then this last one, I have negative 4 times 5 square root of 2. So I'm going to have 12 square root of 2 minus 2 square root of 15 plus 16 square root of 15 minus 20 square root of 2. Now I'm going to combine any radicals that are like. So I have 12 root 2 and I have negative 20 root 2. So that's going to give me negative 8 root 2. Then I have negative 2 root 15 and 16 root 15. So that will give me 14 root 15. And since this is a square root of 2 and that's a square root of 15, those will not add. So that is how I leave my final answer. I strongly recommend you try 18 through 24. Make sure you get those right. You can check them with me. And then you can start on the homework.